Hi students, this is Alex here. In this video, we are going to reduce the quadratic form into canonical form. So the first part, we have to write a matrix A. The matrix A formula is, by using this, we get the matrix A as the first element is 1 and there is no x2, x3, x1, x2 term, so it is 0. There is no x1, x3 term, which is 0, and once again this is 0, and there is no x square term, so this is 0, and there is a x2, x3 term, and half of the coefficient will become 1. Again, this is 0, and this is 1, and this is 0. We got the matrix A. Next step, we have to find the eigenvalues by writing the characteristic equation, which is determinant A minus lambda I equal to 0. So we have a determinant which is A minus lambda I means 1 minus lambda, and this is 0, 0. This is 0, 0 minus lambda and 1, and 0, 1 and 0 minus lambda, which is minus lambda, which is equal to 0. Now we are going to expand this determinant. So we take the first element into product of this will be lambda square, then minus 1, and the rest of the terms are 0. So totally this is 1 minus lambda, and this is lambda plus 1 into lambda minus 1 equal to 0. We have three factors, so the values of lambdas are 1, minus 1 and 1. Let's rearrange this. So the lambda values are minus 1, 1 and 1. For each value of lambda, we have to find the eigenvector. So if lambda equal to minus 1, then A minus lambda I into x equal to 0. So A minus lambda I already we have written. Now we are going to take in the matrix form. So 1 minus lambda 0, 0, 0, and this is minus lambda, and this is 1, and this is 0, 1 minus lambda, and this whole value into x is x1, x2, x3, which is equal to 0. Now when lambda is minus 1, we substitute here, so this becomes 2, 0, 0, 0, 1, 1, 0, 1 and 1, and this whole value we are going to multiply with the column matrix x1, x2, x3, and this is equal to 0. Now when we multiply, this is 2x1 plus 0x2 plus 0x3 equal to 0, and the second row will become 0x1 plus 1x2 plus 1x3 equal to 0. So we take these two equations, we are going to use a cross multiplication method and get the values of x1, x2 and x3. So we take x1, we take 0, 1, 0, 1 determinant, and again when I take x2, we get 0, 1, 2, 0. Then coming to x3, we get 2, 0, 0, 1. So by evaluating this determinant, we get x1 by, this is 0, and here it is x2 by 0 minus 2, which is minus 2, and this is x3 by 2 minus 0, which is 2. So we are going to take the simplest ratio x1, which is 0, x2 by minus 1 and x3 by 1. So the eigenvector, we take it as x1, which is having the numbers 0, minus 1 and 1. Now for the next lambda value, we are going to find the eigenvector. The next two values are 1 and 1. So let's take, if lambda equal to 1. So again, as usual, a minus lambda I into x equal to 0, and a minus lambda I will become 1 minus lambda 0 0 0 minus lambda 1 0 1 and minus lambda. This whole value into x is x1 x2 x3, which is equal to 0. Now we are going to take 1 for lambda. So 0 0 0, then this is 0 minus 1 1, then 0 1 and minus 1. So this whole thing into, we have x1 x2 x3, which is equal to 0. By multiplying the first one, we get everything as 0. So I am going to take the second one. So 0 x1, that is second row with product of this, and minus x2 plus x3 equal to 0. And third one, 0 x1 plus x2 minus x3 equal to 0. So anyway, second and third are same equation, just it is of opposite sign. So I will take the third equation. From that we get x2 equal to x3. So this does not have x1. So I can take x1 as 0, and if I take x2 as 1, then x2 and x3 are equal. So x3 will also be 1. So I am getting the eigenvector corresponding to 1 are 0, 1, 1. Then there must be another eigenvector corresponding to the value of lambda 1. For that, we have to assume it is L, M and N. That is, we take the next eigenvector x3 in the form of L, M, N, and this is orthogonal with x1 and x2. So when I take x1 transpose with x3, it has to be 0. So x1 already we got 0, minus 1 and 1. So if I multiply with x3, we get 0 L minus M plus N equal to 0, because we have 0, minus 1 and plus 1. In the same way, with x2 transpose, we multiply the x3, since they are orthogonal, it has to be 0. So we get again 0 L plus M plus N equal to 0. We are going to follow the cross multiplication method. So L by, this is minus 1, 1, 1 and 1, and M by 1, 1, 0, 0, and N by 0, 0, minus 1, 1. So we have to calculate this. This is L by minus 1, minus 1. So minus 2, and M by 0, and again N by 0. So the simplest form is, we can take the negative also. So that is, we can divide by minus 2. So it is 1, 0 and 0. So totally we got x3 as 1, 0, 0. And let's take x2 here. which is 0, 1, 1, and we take x1 here, which is 0, minus 1, 1. So we got the eigen vectors for the corresponding eigen values. Next we have to combine all this thing and write a normalized matrix. Before that, let's divide everything by its magnitude. This magnitude is root 2. So in the normalized form, so let's take it as normalized form. We get x1 is equal to 0 by root 2 minus 1 by root 2, 1 by root 2. In the same way, the next one also, its magnitude is root 2. So we get 0 by root 2, 1 by root 2, 1 by root 2. And x3 is, magnitude is 1. So even after dividing, we get the same 1, 0, 0. Now using this, we have to write the normalized matrix n. So normalized matrix n will be the first column 0 by root 2, then minus 1 by root 2, 1 by root 2. This is 0 by root 2, 1 by root 2, 1 by root 2, then 1, 0, 0. So we got the normalized matrix. Now for diagonalization, we are going to use a formula D equal to n transpose a n. So D equal to n transpose. So we are going to do the transpose of this matrix. So we are going to take the first row and we are going to write it as a first column. So 0 by root 2, 0 by root 2 and 1. Then second row as second column. Then third row as third column. Then we have to write the matrix A, which is 1, 0, 0, 0, 0, 1, 0, 1, 0. And n is, once again the same matrix we have to copy here. 0 by root 2, minus 1 by root 2, 1 by root 2, then 0 by root 2, 1 by root 2, 1 by root 2, 1, 0, 0. Then we are going to perform a multiplication. So as a first part, we are going to multiply the last two matrix. So we take the first matrix as it is, this D, that is 0 by root 2, 0 by root 2, 1, then minus 1 by root 2, 1 by root 2, 0, 1 by root 2, 1 by root 2, 0. Into, we are going to multiply this. So we take the first row and here first column, corresponding elements we are going to multiply. So this will be 1 into 0, 0, then everything is 0. Then this first row, the second column, again 0, 0, 0. So everything is 0 and the last will be 1 into 1 alone. Then we take this second row and multiply the corresponding elements. Since first two elements are 0, so 0, 0 and only 1 by root 2 will come. In the same way 0, 0, 1 by root 2 will come. Here 0, 0 and this is also 0. In the same way we take the third row and multiply. So this will become 0 minus 1 by root 2 alone will come, and second will be 1 by root 2 alone will come, and the third will be 0. And after this we are going to multiply these two matrices. So first will be, I have to take this first row and multiply with the corresponding elements of the first column. So D equal to, first will be 0, second will be minus 1 by root 2, again minus 1 by root 2. Sorry, the denominator will become just 2. So root 2 into root 2 will become 2. So minus 1 by 2 and minus 1 by 2. So this is minus 1 by 2, then minus 1 by 2. Then multiplying with the next column, we get 0, then minus 1 by 2, then again plus 1 by 2. Then with the last one, which is 0. In the same way, we take the second row and we are going to multiply with corresponding elements of each column. So first is 0, then second is 1 by 2, then minus 1 by 2. 1 by 2, minus 1 by 2. Then this is 0, then again plus 1 by 2, plus 1 by 2. Then the last one is 0 and remaining also 0. Then in the same way, we take this third row and multiply corresponding elements of each column. This will be 0 and again this will be 0 and this will be 1. Now simplifying this further, we get D equal to minus 1 by 2 minus 1 by 2 is minus 1. And this is 0, 0, this is 0, this is 1, half plus half is 1, this is 0, 0, 0 and 1. So we got the diagonal matrix. Now we are going to write this in the canonical form. The canonical form is minus y1 square plus y2 square plus y3 square. So we have taken the elements of the leading diagonals, which are nothing but the eigenvalues of the matrix A, which we got from the quadratic form. Thus we got the canonical form.